2.2. Estimating square roots. So memorizing your perfect squares in this unit is going to be very helpful, and they're going to be serving as your benchmarks. So benchmarks are just absolute perfect squares that we know to be true, and we'll use this word again later on in the video. So 1 squared, 1 times 1 is 1. 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. 4 squared, 4 times 4 is 16. 5 squared, 5 times 5 is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. And 12 squared is 144. Some of you folks, I'm sure, would be able to fill that in on your own. So for some folks, this is going to require a little bit more memorization. But this list right here is going to be really helpful for the next little bit. So it says right here, use benchmarks to approximate the value of each square root. So you're going to notice 82 is pretty stinking close to 81, but it's not 81. So it's not a perfect square. This one right here, 50, it's pretty stinking close to 49, but it's not 49. And we're going to use our knowledge of decimals to help us out with this last one. So let's just start with this one, A. So remember, whenever we say use benchmarks, all we're thinking about is our perfect squares. So use what we know to be true with our perfect squares to help us out approximating this. So if I were to say the square root of 82, that's sandwiched between the square root of 81 and the perfect square that's above it is 100. So that means that I'm gonna evaluate these here. That means that the square root of 82 is somewhere between 9 and 10. We know that 82 is closer to 81 than it is to 100, so I know that my square root of 82 is going to be closer to 9. So if I were to write this out, I would say 82 is approximately, that's equals approximately 9.1. I'm going to allow for a lot of variation here. Probably 9.5 I would take maybe a half mark off, just because 82 is clearly closer to 81 than to 100, and it's not smack dab in the middle. So that's why I'm looking for this 9.1. Because 82 is closer to 81 than it is 100, and we know that square root of 82 is between 9 and 10. Let's use this method for the square root of 50. So I'm saying that the square root of 50 is between the square root of 49 and the one that's above it, so square root of 49, and the one above it is 64. So that means that the square root of 50 is somewhere between 7 and 8. 50 is closer to 49 than it is to 64. So if I were to write this out, square root of 50 equals approximately 7.1. I'm just saying that because 50 is closer to 49. Okay, let's look at this C. Now, I'm noticing that I don't have any decimals here. So this one right here, I know it's going to be less than 1, but let's use what we know of perfect squares and combine it with decimals. If I were to say 0.3 squared, let's use our calculator to help us out with that. 0.3 squared is 0.09. And if I were to say 0.4 squared, 0.4 squared, that's 1.16. sorry, 0.16. So what I'm saying is I can use my knowledge of decimals to help me out with this next one. So I chose those ones because 0.11 falls between 0.09 and 0.16. So I'm saying that the square root of 0.11 lives somewhere in between 0.09 and 0.16. That means the square root of 0.11 lives somewhere between 0.3 and 0.4. I'm saying that it's much closer to 0, it's not much, it's closer to 0.09 than it is to 16. The difference here is 0.02, and the difference here is 0.05. So I'm going to say the square root of 0.11 equals approximately 0.3, I'm going to say 2. Let's just try something over here. Say I would have 1.2 squared. Let's do this the old-fashioned way. 1.2 times 1.2. So 2 times 2 is 4. 2 times 1 is 2. Put a placeholder here. 1 times 2 is 2. 1 times 1 is 1. And then we add it all together. 4, 4, and 1. Now what we need to do here is we need to take into consideration the decimal places. So we have 1 decimal place here and 1 decimal place here. So that means that in my final answer, I need to make sure that I put my decimal place in 2 spots in. So that means that 1.2 squared is going to be 1.44. Or the opposite that I can say is the square root of 1.44 is 1.2. So let's look at this for a second. So does that mean that if I take the square root of 0.144, it's going to be some kind of representation of 12? Well, let's just see. So 0.144, and I find the square root of that. It's not. 0.379, 0.379, So it just means that this one right here is not a rational number. So let's look at how many decimal places there are. So for a decimal place, for a 1 decimal place, we know that the square or the square root will have, or the argument that's under the square root sign is going to have 2 decimal places. What about the square root of 0.0144? Let's try that. Look at that. It's some configuration of 12. So if we notice the pattern here, this is 2, this one is 3 decimal places, and this one is 4 decimal places. So when you have arguments with an even number, we know that it's based on the regular number that's associated with it. But if we have 3 decimal places, it changes that. Or if we have an odd number of decimal places, it changes that. Try that with a few different ones. Like, why don't you try 0.9 on your own? So 0.9 times 0.9 and figure that one out. Okay. So example 2, this one just has to do with fractions. So determine an approximate value for each square root. So when given fractions, simply replace the non-perfect square number with the closest perfect square. So if we were going to go to A, and I find the square root of 1 over 35. I'm just going to split it up a little bit. I'm going to say the square root of 1 divided by the square root of 35. So the square root of 1 is just 1, but let's look at our list here. What's this perfect square that's closest? We have 25, we have 49, we have 36. That's pretty close to 35. So I'm going to say the square root of 1 divided by the square root of 35 approximately equals, the square root of 1 is just 1, over the square root of 36, because it's so close. Okay, and that equals 1 over 6. Let's look at the next one. The square root of 85 over 4, and I'm just going to split it up into the numerator and denominator so I can simplify them differently. So that equals approximately the square root of 85. Let's see what that's closest to. We have 64, we have 81, and we have 100. Our 81 is closest to 85, so I'm going to say that equals approximately the square root of 81 over the square root of 4 is simply 2. So then that would just be 9 over 2. And that's that. I just want to take a moment right now just to talk about kind of the subtle differences between and some common mistakes that people make. A lot of people say the square root of 25 is the square root of 5. I'm going to draw a big red X through this because that is not right. The true thing is the square root of 25 equals 5. That's it. This is a very common mistake because the square root of 5, if I were to say the square root of 25, that is just plain old 5. If I were to take the square root of 5, that's definitely not 5, okay? So the square root of 25 would definitely not be 2.236067977, blah, 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 going on forever. We want to say that this is another common mistake, actually. 36 squared is 6. I'm going to put another big red X here. 36 squared, let's think about it. 36 squared, let's find that. 36 to the power of 2 is 1,296. Okay, it is definitely not 6. But 6 squared is 36. Okay, both of these two things are correct. So we have a relationship here, an inverse relation. So if I say the square root of 25, that's 5. Another way that I can express these numbers together is I can say 5 squared is 25. Okay, these are all right. Anything that does not have a red X through it is correct. So let's write a quick summary here. So a benchmark, they are perfect square numbers that we know. That can help us approximate or estimate. Square roots we don't know. If we are given a non-fraction, use the benchmark above and below. If we are given a fraction, just use the one that is closest. All right, so go and do your Math IXL, and then come and grab your mastery check.